We have actually had some exposure to universal functions before in the course when we were doing ND-array plus ND-array operations and ND-array minus ND-array operations. Those were universal functions. The whole point of universal functions is that they make the element-wise operations much easier as compared to trying to do them with loops in Python. Let's explore that one more time. What we've done here is created two Python lists, and we've tried to add them together. And what we find is that we get this list right here added to this list right here, which is a group-wise operation. It's not an element-wise operation, and it's not very useful. In order to do a group-wise operation here, we have to use a for loop. This is a comprehension. If you're not familiar with comprehensions, there's a very straightforward tutorial on those in a previous data science course just on the Python programming language. But basically what we're saying is create a temporary variable called value. The first time value is going to be equal to 0, so we're going to be adding index 0 to index 0 in list 1 and list 2. The second time value is going to be 1, so we're going to be adding list value index 1 to list value 2 index 1, and likewise until we get all the way to index 3 right here. Let's run this, and it works because 2 plus 1 is 3 and 4 plus 10 is 14 and so on. Yes, it works, but this creates a lot of friction, not just for us as programmers, but also for the computer regarding mathematical efficiency. It's just not efficient. If we take our Python list 1 and convert it to an NP array and do the same with list 2, we can simply add these, which is much easier for us programmatically, and it's also much faster computationally. And there are many other universal functions. We call them ufuncs. We already looked at plus and minus and times and division, but there's also some more abstract ones. For example, this exponentiation here. Exponentiation is going to do something that we may not expect. It takes Euler's number, 2.718281 dot 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 dot. This is an ongoing number similar to pi, and it'll take all the numbers in list 1 and it'll raise Euler's number by the second power, and then it'll raise Euler's number by the fourth power, and then it'll raise Euler's number by the sixth power, and on like that. And this may seem obscure to us, but basically it helps calculating the slope of a curve, basically. It becomes useful later in data science, but if we run this, then Euler's number has been raised to this power, and this power, and this power, and it creates a new array. The square root function is more straightforward, because we know the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. So this actually returns something more expected to us. And the square root of 49 is 7. This one is more interesting. It's the maximum method. The maximum method takes two arrays, and what it does is it compares the two arrays. It will compare index 0 of both arrays and say, okay, well, what's the maximum value in this comparison? In this case, the maximum is going to be 2 because 2 is greater than 1. For the index 1 comparison, the maximum is 10. For the index 2 comparison, the maximum is 6, and so on throughout the array. Let's run this one. So 2 is greater than 1, 6 is greater than 3, and 8 is greater than 4. That's the maximum function. Now, there are many more functions, universal functions. Some of them perform expected operations, and some of them perform unexpected operations, but you can find a full list of them and their descriptions at this link.